All right, welcome to The Explainer. Today, we are tackling one of the weirdest, most mind-bending experiments in all of physics. Seriously, it's an experiment that seems to show that the future can actually change the past. Yeah, you heard that right. This is going to force us to question everything we think we know about time and reality itself.
So here's how we're going to break this down. First, we'll get into that classic quantum headache. Is stuff a wave or is it a particle? Then we'll see how just looking at something totally changes the game. From there, we'll explore this wild idea. What if you could erase what you saw? We'll set up the experiment itself, the delayed choice quantum eraser, and then, hoo boy, we'll look at the results. And finally, we'll try to wrap our heads around what it all means.
So this is it. This is the big central question. Can something that happens in the future literally decide what happened in the past? I know, it sounds completely nuts, right? It violates everything we think we know. But as we're about to find out, the quantum world, well, it doesn't really care about our rules. Okay, so before we can even touch the main experiment, we have to get our heads around this one fundamental weirdness of quantum mechanics. It's this idea that really tiny things, like photons of light, they kind of live a double life. And that double life is called wave-particle duality. So what does that mean? Well, think of a single particle of light, a photon. Sometimes it acts like a little tiny bullet, a particle. But other times, it acts like a wave, like a ripple spreading out in a pond. The crazy part is, it's not one or the other. It's somehow both. And what it decides to be depends completely on whether or not we're looking at it. Okay, and this is where it gets really visual. This is the famous double slit experiment. On the left, imagine we're firing photons at two slits, but we're not checking which slit they go through. Look what happens. They act like waves going through both slits at the same time, and they create this beautiful interference pattern on the screen behind. But now look at the right. The only thing we changed is we put a little detector there to see which slit each photon goes through. And bam, the interference pattern completely vanishes. Now they just act like little bullets, making two simple stripes. The wave is gone, just because we looked. So this whole act of observing thing, it's not just a small detail. It changes everything. It's like the universe itself holds its breath and behaves differently the moment it knows it's being watched. And this is so important to get. We're not just, bumping into the photon and messing it up. The very act of knowing which path it took, getting that which path information, is what forces it to stop being a wave of possibilities and pick a side. It has to become a particle. That whole cloud of potential just collapses into one single reality. Because we peaked. Okay, now this is where the real fun begins, because some physicists asked a truly brilliant, almost mischievous question. If knowing the path destroys the wave pattern, what if we find out which path it took, and then somehow we forget? What if we could erase that information, right? Could you actually get that beautiful interference pattern back if you erase the which path information? It sounds impossible. I mean, the choice was already made. But in the quantum world, information isn't just something in your brain. It's a real, physical thing. And if it's physical, well, maybe you can get rid of it. And that incredible question brings us to the main event, the delayed choice quantum eraser. This isn't just some sci-fi thought experiment either. This is a real thing that scientists have done. And the results? Well, they're staggering. Okay, let's walk through this setup. It's a bit of a maze, but stick with me. First, a special crystal spits out two photons that are entangled. Think of them as quantum twins. Whatever happens to one instantly affects the other, no matter how far apart they are. So photon 1, let's call it the signal photon, takes a short little trip straight to our main detector. Easy. But its twin, photon 2, the idler, goes on a much longer journey. And at the end of its path, it hits this series of mirrors and detectors. And this is where the choice is made. Depending on which detector photon 2 hits, we either find out which path its twin took, or that information gets completely scrambled, erased. And check out this number, 7.7 nanoseconds. That's the secret sauce. See, they intentionally make the path for that second photon, the idler, much longer, so there's a delay. And this tiny little gap in time, that's what makes this whole thing so unbelievably weird. Seriously, let this sink in for a second. Photon 1 has already hit the detector. Its journey is done. It's in the history books. It either acted like a wave or a particle, and that event is in the past. Then, A whole 7.7 nanoseconds later, its twin finally finishes its long journey, and that's when the choice is made to either know or erase the path information. It really, really looks like a decision made in the future is dictating what already happened.
So, what did they find? When they look at the data, what does the pattern from photon 1 look like? You'd think it would be the same no matter what, right? Its journey is over. But no. Incredibly, the pattern it left behind depends entirely on what happened to its twin nanoseconds later. And here are the results. It's just wow. Look on the left. When we sort the data and only look at the photons whose twins told us the path, we get nothing, just a blob. Classic particle behavior. But now look at the right. When we look at the photons whose twins erased the path information, the interference pattern is back. It's right there. It's as if photon 1 somehow knew back in time that we were going to erase the information in the future, so it decided to act like a wave.
And hey, don't just take my word for it. This is a quote from the actual scientists who did the experiment. They're saying it right there. You can erase or mark the path information using the entangled twin, even after the first particle has already been detected. It's wild.
So, what does this all mean? Did we just prove you can change the past? Is causality just broken? That's what it looks like at first glance. But the real answer is a bit more subtle and, honestly, maybe even weirder.
Okay, here is the big reveal, the twist in the story. If you look at all the data from photon 1 at once, without sorting it, you see nothing, just a fuzzy, meaningless blob. So we're not actually reaching back and changing a past event. What's really happening is more like we're revealing a hidden order. Think of all the data from photon 1 as a scrambled message that's already been delivered. The information we get later from photon 2 is the key to unscramble it. It doesn't change the message, it just allows us to read it. When we use that future key to sort the past data, these two different patterns, the wave and the particle, suddenly pop into view.
So, what's the bottom line here? Well, first, observation isn't passive. It literally helps define what is real. Second, entanglement is spooky stuff. It connects things across space and time. And maybe most importantly, the story of a quantum particle isn't really finished, isn't set in stone, until the entire experiment is over. The patterns we see aren't just out there, they emerge from the way we choose to slice up the data. What this experiment really does is it blows up our comfortable idea that the world is just a bunch of stuff with fixed properties waiting for us to find it. It suggests something much stranger, a universe that exists as a haze of pure potential, a sea of possibilities, and those possibilities only collapse into a concrete what happened when the measurement is finally complete. Which leaves us with maybe the deepest question of all. If reality isn't fixed until we look, what is it the rest of the time?